Hey everybody, I just wanted to introduce Excel to you. Excel is one of the programs in Microsoft Office that we're covering in this course, and it is one of the most widely used business tools out there. Pretty much everybody uses Excel, whether you're a manager in a big company, the owner of a small company, everybody uses Excel. Even my sister-in-law, who's an Imagineer for Disney, right? She designs stuff for the theme parks. She eventually had to use Excel because she got so good at what she did, they entrusted her with a big budget, and that requires monitoring and analyzation and all that sort of stuff. So whatever career path you choose, there's a good chance you're going to end up crossing paths with Excel. Now, Excel is a tool that's used by businesses to essentially track things, budgets, inventory, sales projections and numbers. And then you take all this data that you've collected and you can use really sophisticated tools to analyze it, to kind of give you some insight into what your business is doing so that you can then make better decisions going forward. Excel is great at that. A lot of people use it for that reason. One of the things I'm going to do is I'm going to show you a little snippet of a documentary called Triumph of the Nerds. It was done by PBS, just a small portion of it, but it's the people who actually created the electronic spreadsheet, all right? And by understanding why these business students decided to create an electronic spreadsheet and know kind of why they created it that way, it may give you some insight as you're using Excel to know why it's designed the way it's designed and how it works the way it works, right? It may just give you a little bit of a better insight as to what you're doing as you actually use the program.
For the Apple II, this application was called VisiCalc. It came straight from the blackboards of the Harvard Business School. Invented by a graduate student, Dan Bricklin, with his programmer friend Bob Frankston, VisiCalc was the first electronic spreadsheet. A spreadsheet is a tool for financial planning, bringing together for the first time the seduction of money with the power of microcomputing. Dan Bricklin's professor at Harvard showed how companies used a grid of numbers on a blackboard to work out profits and expenses.
60 down here, and your profit would be this minus this, which gives you 40. And then, well, let's see, what's the sales growth? We'll say there's a 10%.
The trick to a spreadsheet is that all the values in the table are related to the others. So changes in one year would ripple through the table, affecting prices and profits in subsequent years. Students were asked to calculate how future profits would be affected by various business scenarios. It was called running the numbers, and they did it laboriously, by hand.
Well, let's say your initial costs have 100 fixed cost at the beginning, so now you have a minus 20 is how much you make the first year. And then the second year you have 100, but your variable, let's say, is 25. So now you're losing, what is it? There's a pain in the neck. I wasn't very good at this stuff. 80, what? No.
We failed. We just lost.
Minus 15, right? And then eventually you're making money. What year do we make money? And and how much does the cost of money? That's what running the numbers was.
Because each value was linked to the others, one mistake could mean disaster.
It blows all your numbers afterwards because you make all your calculations based on other numbers before them. If I had miscalculated...
Dan, who had worked as a programmer, started daydreaming about how he could use a computer to replace the tedious hand calculations.
I imagined that there was this magic blackboard that did like word processing does word wrapping. If you make a change to a word, it automatically pulls everything back. Well, why not recalculate the same way? So that if I changed my number, I should have used 10% instead of 12%. I could just put it in and it would recalculate everything, go through it. And that would be this idea of electronic spreadsheet.
Following a model that's common today, Dan Bricklin designed the program, but got his friend Bob Frankston to write the actual computer code. After months of programming late at night, when computer time was cheaper, the Harvard Business School blackboard came to life.
Now we've set this up, okay? Then we type a new value in, okay? Here I'm going to take that 100, and I'm going to change it, right? And here, it recalculated. Whoa! That saved me so much time.
People who saw it and went and got it, but like an accountant, I remember showing it to one around here, and he started shaking and said, "That's what I do all week. I could do it in an hour. What I could do, and they would take their credit cards and shove them in your face." I meet these people now, they come up to me and say, "I got to tell you, it's...
you changed my life.
Changed my life. You made accounting fun." And
All right, everybody. Now let's take a practical look at Excel. I'm not entirely sure that we can make accounting more fun, but hopefully we can make it less painful. Now, this is probably a different version of Excel than you'll have at home. I'm working on a Macintosh, but I want to speak in concepts here. When the Office 2016 version comes out, chances are they're going to move the buttons anyway. It's better to understand the concepts so that whatever version you're using at home, you'll have a better idea of how it's working. And hopefully that will give you some insight as to what buttons to use when. So the first thing we're going to do is look at the file itself. Now, a file, XLSX file, is comprised of several spreadsheets. There's little tabs down here that allow you to sort of bounce between all the different spreadsheets. Now, each sheet in the file has this sort of grid, right, with all these cells. That's what we call these individual little squares here. And each cell can hold a piece of information, either a value or a formula. We'll get into those formulas in a bit. The name of the cell comes from the column that it's in and the row that it's in. So this is cell C4. And you can actually see it listed right here in the name, sort of this little naming area over here. C4 is the cell. If I go over here, this would be cell F12, and you can see F12 right there. So every cell on the sheet has a name, and each cell can hold a value. So if I click here, cell A1 holds cell A1, the name is A1, it holds a value of 1. That name is not valid, whatever. It holds a value of 1, right? Meaning that I actually put a number in there, whereas this one has a value of 2, this one has a value of 3, etc. So cells can hold some sort of a value. Now I can also refer to a range of cells. So if I want to refer to the range of cells from A1 all the way down to A10, right, I would write that as A1 column A column colon A10. A1 colon A10 means the range of cells from A1 all the way to A10. And in fact, if I wanted to select a different set, I'm going to actually type it in here as opposed to highlighting. I could say C6 colon C, I don't know, 12. Well, that will highlight this range, right, from C6 all the way through C12. And they don't actually have to be ranges in the same column. So I could say, C6 colon F6, right? Well, this would be different columns, but all in the same row, right? I could say C6 colon G16. Now that's actually going to be a whole range, starting with C6 in the upper left and going all the way down to G16 at the bottom right. So there are different ranges. So those ranges are separated by colons to kind of tell you what cell to start at, what cell to end at. All right, so cells have names, ranges have names, and cells can hold different values. Now, if I were to change this value, right, make it, let's say, 12, no problem. Now this has a value of 12, this has a value of 2. One of the things I can do is instead of typing in a value into a cell, I can actually type in a formula. All right, now a formula is not a static value. It's not a value that's just going to stay the same. This 12 will always be a 12. Doesn't matter what I do in the spreadsheet, that 12 will always be a 12. That's why we call it a constant, right? It is constantly going to be 12. Whereas over here, if I type the formula equals A1, hit enter. Now this has a value of 12. But you notice that when I click on it and I look over here in the formula bar, I don't see a 12. I see a formula. Whereas over here, I'm actually editing that formula now. Hit enter to get out of that. Whereas if I click over here, I actually see the 12. When I click here, I see the formula. The idea is that if this number were to change, let's say I were to change it to 42. Well, now look, this number changed with it. So this value isn't a constant. this value will actually change in relationship to other values on the table, right? And so that can allow you to do various things. Like, so here, if I were to say A1 times 2, now you notice I use a little star here. That's because the X doesn't really kind of work for multiplication in Excel. So we use the star to represent multiplication. And just so you know, we use the slash to represent division. So in fact, here I'm going to do A1 divided by 2. So I get 21, right? Because 42 divided by 2 is 21. Now if I were to switch this to 108, now I get 54, because 54 is half of 108. So this is always going to do math based on the value 1 to the left, okay? That's the idea of formulas. It's what makes Excel so powerful, that I can actually change numbers in reference to other numbers. So let's say I've got this relationship right here, A1 divided by 12, or divided by 2. This formula, I can actually copy and paste. I can do that by hitting Control C or Command C, depending on whether or not you're on a Mac or a PC. And then I can do Command V and actually paste it here. Now notice it's doing the exact same thing. It's taking the cell that's 1 to the left, which in this case is 2, dividing it by 2, and that gives me 1, right? Now there's actually a faster way of copying and pasting. This little dot right here in the bottom right-hand corner of the cell is called a fill handle. And when I put my cursor over it, my plus sign goes from a big white plus to a sort of a thin black plus. Once that happens, I can grab that fill handle and drag it down. And that's the equivalent of copying and pasting that first cell all the way down. And you can see that now, hey, look, each one of these is giving me exactly half of the cell to the left. I've effectively copied and pasted my way, through a whole range of cells. Now, the reason we do this is because in accounting, it's very common that you want to sum up a whole bunch of rows or a whole bunch of columns. And so having that ability to copy and paste a formula across the sheet is actually really valuable. One of the other things I can do is I can change the formatting of things. So let's say that I wanted all of these numbers to actually represent currency as opposed to just numbers. Well, then I can go over here and switch it to currency, and hey, look, now it's $2.50, which is exactly half of 5, right? So I can change the way I format things. I can change the way I set up formulas. Now here, and I do that using what we call references. So when I said equals A1 in that very first cell, right? That reference to A1 is referencing this cell. We call it a reference, and you just put in the name of the cell you want to reference. That's how you reference it. That reference is always what we will call a relative reference. Now, I won't get into relative versus absolute references here, but just so you know, when I copy and paste this, you notice that this one, whoops, I'm now editing. I'm going to hit Control Z to undo that, hit Enter. That here I don't have A1, I have A2. That's because Excel assumes by default that you want to do the more common accounting task, which is I actually don't want this cell every time. I always want the cell that's 1 to the left. It's called a relative reference. Now there is a way of using dollar signs to create an absolute reference, so it always refers to this as one exact cell. But the advantage of that is as I copy and paste, you'll notice A3, A4, A5. That reference changes as we go down the column, right? Excel just assumes that that's the behavior that I want because it's the more common behavior in accounting. Now, let's actually look at a live budget. So let's say I'm doing a concert, I've got a budget, and so I've set up some budgeted numbers here. I can do stuff like this, for instance. Here I just want to total these numbers above. Well, there's a function called sum that's built in. Now it actually also has a very quick and easy to use button using that little Greek sigma letter, but that allows me to sum all of the numbers between B6 and B9, which is B6 through B9, and just put the value there. Here I can determine net profit and loss by subtracting whatever was in B10, my total income, from B21, which is my total, or sorry, B20, which is my total expense. sorry, B21 is my total expense. Subtract this number from this number and you should get this number. But that means that if I decide to change my budget and I say, you know what, I expect us to make $6,000 in concession sales. Well, now my net profit and loss should change as a result, right? Making a change in one number will cause the numbers in other places to split. And it also allows me to do some more complex things. This, for instance, is a formula that I won't necessarily explain by now, but it actually does create a 60-40 split with whoever the band is. A door split is usually you take the total amount that came in from ticket sales, not including concessions, not including merchandise, so just ticket sales. You subtract the amount you spent on the venue, labor, equipment, promotions, and then you take that number, subtract it from that number, and what's left you split, giving 60% to the band. So in this case, the talent will cost me $7,200. But if I say that I think we could actually make $25,000 in ticket sales, well, now I owe the band more money. But if I think that I'm going to increase merchandise sales and actually make $5,000 in merchandise sales, well, that doesn't affect the band at all because merchandise is, in this case, me, although I think in the real world it would normally be the band. So you can kind of see how these numbers are related to other numbers, and we can actually get more complicated. Over here in the actual, these actual numbers actually come by looking at, so like venue, right? This venue number comes from actually looking at expenses on a different sheet and looking at the category, and if the category is venue, it takes whatever the amount of that transaction is and adds just those together to create this number, right? As you learn more about Excel, there are bigger and bigger tricks you can do like that to essentially create things where, hey, I've got just a list of expenses, and as I add expenses, it'll add to my total expenses, but I can actually budget and place them in the correct categories. Income, I can actually break up what type of income I have and how I earned it, and have that reflect on this budget sheet, right? Lots of tips and tricks as you learn stuff as you go on. But for right now, I just want you to get some of the basic concepts. One, multiple sheets per file. Each sheet having lots of cells that have names that you can refer to by the letter, the column letter, and the row number. Ranges you can refer to using a colon and wherever you want the range to start and wherever you want the range to stop. So this would be D5 colon F12. Knowing that you can change the formatting of numbers simply by going over here and deciding how you want the number to look. Maybe these should be times, which they're not represented as times, so that doesn't look good at all, but I can just turn them back into regular numbers. I can change the amount of decimal places that I want to have appear, right? Maybe I only want 1 decimal place, right? So I can change the formatting of numbers. I can create formulas that use references so that as other numbers change, these numbers can change as well. And I can even use fancy functions like sum, which will automatically say, hey, look, I think you want to sum up these numbers. Sure do. Hey, look, 135. That would be the total of all these numbers. Those sorts of basic concepts, I think, will be enough to sort of give you a scaffolding upon which the simulations can add additional knowledge and detail. All right, so good luck with Excel. If you have any questions, as always, email me, brian.baker@fresnocitycollege.edu, and I will see you online.